Hi APE students, welcome to video 32 on water resources and pollution. So at the end of this video, you should be able to identify where we get our water and what we use it for, list and describe different water pollutants, explain how pollutants enter our water, and distinguish between a point and non-point source of water pollution. So this diagram shows you all the world's water if you sucked out all the water from the oceans. So everything is dry here. So this big bubble is the amount of water on the planet total. The smaller bubble right here is the amount of fresh water on the planet. And then this tiny itty bitty dot is the amount of potable water, meaning that that's the amount that humans actually can use for whatever purposes. So here's a picture of Earth, 6 billion kilometers away. It was taken in 1990 by the Voyager space probe. And this is when we really realized and named our planet the blue planet, because we have so much water, we look blue in space. So here's where Earth's water is distributed. So definitely need to know 97% of the water on Earth is salt, 3% is fresh. Of that 3% that is fresh, most of it is ice caps and glaciers. So 70% is going to be locked that we can't really do anything with. And then about 30% of that is going to be groundwater and surface water. So if you look at the 3%, 2% basically is ice caps and glaciers, 1% is everything else. And then our fresh water on the surface, so looking at this surface water, which is 0.3%, you're going to have lakes, swamps, rivers, all representing where we get most of our water for drinking from. So looking at aquifers, this is where a lot of our drinking water comes from. Half of it, if it's not from the surface, like rivers and streams, it's going to be from an aquifer, groundwater basically. And we know that water tables are falling, mainly because of irrigation. That's the number one thing that we use water for, is to water our crops. And places like India, China, the US, we produce a ton of grain, and this requires a lot of water. So we're over pumping our aquifers for irrigation. So this is a picture of Saudi Arabia. This is before we started pumping water for irrigation. This is after, so you can see all this green is agricultural land. Looks awesome, but you're getting this water from the ground because there's no surface water in the area to actually pump and make your crops from. So back in the US, we have our biggest amount of depletion for water is in this region around Texas and the Midwest. This is an area called the I hate pronouncing this word, Ogallala Aquifer. That is the largest known aquifer that we have in the entire world. And unfortunately, we are extracting water from it way more than is being put back. So eventually that's going to be depleted, and our crops are going to suffer from that. So when we look over here, you do need to know these zones and kind of how they're situated. So the zone of saturation is where there is completely water. So all the pore spaces in the soil is filled with water. Here's your water table where you can actually drill down and get water if you had a well. And then here's the zone of aeration. So this is where you have pore spaces, but they're not filled in with the water. So looking at this map, if you'll notice, hang on, I'm going to go back for a second. So this is where your area of high and moderate groundwater overdrafting is. And then if you look here, you'll notice that this is also the place where we get the least amount of rainfall. So that's why we're taking out more than what's being put in. So here in North Carolina, we actually get a pretty good amount of rain. So we don't have too much to worry about for our groundwater depletion. But a lot of our agriculture and our crops come from this part of the world, or from the United States. So we still are going to have to worry about that in the future. So one of the biggest problems that actually can happen when you are pumping groundwater out of the ground is something called subsidence. So this is the gradual caving or sinking of the land, in this case because we're pumping water out of the ground. So this is a very striking picture. This shows you what the elevation was like in 1925. And then this is down here in 1977, and it has continued to go down, and we have literally pumped the water out of the ground, and it has slowly sank over time. So this is a kind of crazy and striking picture to see. So these are areas of the world that are really, really stressed for water. You'll notice that most of them are around the equator where it's the hottest. Lots of places in Africa. We also have some in the Middle East. India is definitely vulnerable. And these are places that are only going to get worse. And a lot of people are thinking that the next world war is going to be fought over water rights. And we see that happening already in some countries. So some other negative effects of groundwater depletion, we know that wells are going to dry up. If you're pumping water from the ground and you continue where the water table goes below your well, then your well is dry. You also have reduced water in streams and lakes because what's happening is if you're pumping the water, these are the natural flow conditions, water's going into the lake. But if you add a well over here, you are drawing water now out of that stream or lake and you're pumping it up out of the ground. So you actually change the flow that's going to that natural source. You also have increased pumping costs. It costs more money to drill wells that are deeper, and your land use is going to decrease. So what used to look like this for agricultural land is going to start to look more like this. So this idea of desertification, if you remember that from our land use unit. And specific to North Carolina, we have issues of saltwater intrusion. So basically, what we have is people living along the coastline. They have wells and they're pumping fresh water out. Eventually, they pump so much fresh water that salt water from the ocean starts to come in and take the place of that fresh water, and it actually moves into your well. So now this well is going to be completely unusable because now you're pumping salt water. This well over here is still fine because there's fresh water, but eventually the salt water is going to move in over here as well. And you're going to constantly be pumping a new well to try to get fresh water again. So is desalination an answer? A lot of students always ask about that. So we're removing salts from water. It is a solution in some cases, but it's very expensive. You can do it by two ways. Distillation, which basically has the water evaporate from like a container. You're left with salts behind. Or you can do reverse osmosis, which is basically you are shoving the water through a very fine filter, and it is filtering out the fresh water. As you can imagine, though, both of these things are very slow processes. They take a lot of money and so a lot of time. So our best solution is going to be to actually preserve the water that we have. And then Saudi Arabia is doing desalination, so are a lot of different places. Saudi Arabia has the most number of desalination plants right now. So looking at our water use, something just like we've had ecological footprints before, a water footprint is the volume of water you directly or indirectly use. And then there's something called virtual water. So virtual water is indirect use. So if you eat a hamburger, it doesn't seem like water really, takes a lot from that hamburger, but it does. It requires 2,400 liters of water to make a hamburger because you have to feed the cow, you have to water the cow, grow the crops for the cow with water, all those sorts of things. So the average American uses about 260 liters per day, and then most people in the world, the poorest and developing countries, are using only 19. You'll remember we did our walk for water activity, and they're using a lot less than we are because they have to carry it all a lot of times. So what are some solutions to our water waste? Recycling water in industry would definitely help. Use drip irrigation, fix water leaks in our home, even raise water prices. If it costs more, then people wouldn't waste it. So get a couple of these different things down to be able to talk about. Another example is xeriscaping. This is basically using native plants in your yard instead of any kind of species that might not naturally grow there. We saw this when we went to the well-fed community garden. In the front lawn, they have a bunch of natural native plants. And so the native plants are going to use less water because they're adapted to that in a region that has less water use. So switching gears a little bit, what happens when our water becomes polluted? That's one of the biggest issues that we have. So talking about water pollution, it's any chemical, biological, physical change that happens in the water, and it basically makes our water unusable. So this is kind of the classic picture of pollution, but sometimes we can't even actually see water pollution. Who does it impact? There's 3.4 million premature deaths every year. Almost 2 million people die from diarrhea. A lot of times they're children, and there's about 1.5 million illnesses that stem from not having enough water or having water pollution problems. So water pollutants come in different variations. So we have infectious agents. They're going to be bacteria and viruses that are in the water that will make us sick. Inorganic chemicals are from industry and household chemicals. So any of these things right here, believe it or not, people actually pour these down the drain and it mixes with our water. Organic chemicals is going to be anything like oil, gas, plastics, detergents, anything that's made from oil or gas products. Plant nutrients or nitrogen, phosphate, we've talked about that a lot, that can cause eutrophication. Sediment is the number one pollutant actually in our waterways. It is soil from erosion. And then you have heat pollution from power plants and industry. And here's a picture down here, thermal heat that's coming out of the power plant that's going to warm up the water and cause different problems. So some sources of these different pollutants. Number one is agriculture. So sediment is mainly from the agriculture, soil erosion. Our fertilizers, our bacteria from livestock, food processing, all of these different processes produce lots of pollution and waste. You also get it from industry. It can be toxins, heat, oil, anything that needs to be dumped is going to be considered pollution and waste. And then we also know that we get it from mining. We get toxins, we get acids that create acid mine drainage. You break up sediment, which contributes to sediment pollution. All of these things are connected. So when contaminants get in the ground, they travel with the water as it travels under the ground naturally. So here's your sediment plume or your pollution plume, and it is going to travel in whatever direction the groundwater is going. So this well over here would eventually be contaminated if this person's getting their water from that source. When sites are really polluted, oftentimes from industries, they're considered Superfund sites. So a Superfund site is U.S. land that's identified by the EPA as being extremely toxic, hazardous waste. People can't or shouldn't live there. There's a bunch of different sites, even in North Carolina. So here's all the different places that we have. One is actually on NC State's campus, where they have their nuclear reactor, and they have produced hazardous waste, nuclear waste from that site. And here's the locations across the entire U.S. You'll notice a lot of them are along the East Coast. A lot of that is because of coal dumping and different things like that, like our coal ash Duke spill that we talked about earlier. So it's kind of scary when you think about how many places are deemed hazardous waste. And imagine the ones that probably are not deemed but should be. So we've talked about point and non-point sources before. Now we're specifically talking about water pollution. So remember, a point source is a identifiable source like a pipe or a drain. Sewage treatment plant would be an example. A non-point source is something that covers a very wide range. So runoff from agricultural fields. It's not easy to find that single source. So just make sure you remember that. This was from Unit 1. Some solutions to these non-point sources are reducing water runoff in the first place. We can also create buffer zones near streams. So in other words, the water has to travel through a lot of vegetation before it gets to the stream. That will clean it. You can do soil conservation methods that we talked about before. Only apply the amount of pesticides and fertilizers that we need to reduce all these water problems. With point source pollutions sources, it's a little bit more complicated. You have to enact laws because usually these things are coming from industries. So example, before 1988, it was legal to dump your industrial sludge waste into the ocean. So the Ocean Dumping Ban Act barred people from doing that. In 1972, we enacted the Water Pollution Control Act, where the EPA established regulations for discharges of pollutants. And it was amended in 1977 with the Clean Water Act. The EPA set quality standards for all contaminants. So this and this are the same thing. This is the Clean Water Act, basically from this situation. So the Water Pollution Control Act created the Clean Water Act. And then the Clean Water Act in 1977 also funded the construction of sewage treatment plants. So we started to clean our sewage before we dumped it in the ocean. All right, that's it. Be ready for a quiz tomorrow.